Hello, I am Spandana. I am a research fellow at the School of Cultural Texts and Records. Today I shall talk about digital text. The question that comes to our mind right after hearing this is, what's a digital text? Well, nowadays we read texts from ebooks, PDFs, sometimes from the plain text files and Word files too. But not all of them really contain digital text. So what do I mean by digital text? Simply put, it is something that the computer can recognize as text, in contrast to an image or a program file. It is an electronic version of a written text. To be more specific, the computer should recognize it as a string of characters saved in a format that the PC understands. I can write computer programs or commands using English alphabet and numbers. But that will not be a string. Rather, it will be a set of instructions for the PC to follow. I can write program with instruction to save a sentence as a text file. Only the sentence specified will be saved as text, and the rest will be a set of instructions regarding what to do with that specific sentence. But there too, the computer has to recognize the characters or words written in the program file to understand what the instruction is. So in a way, these two are kinds of digital text. You may say, what's the point of saying all this? But suppose you scan a page from a printed book on some programming language. The page contains the same program we are talking about, a set of instructions to save a sentence as a text file. The computer will not understand a word of it and do nothing. This is because the scanned page is actually an image file. In an image file, the computer only gets color information. It divides the whole image into bits and pieces and stores the color data about each smallest unit visible on screen. To the PC, if there is a word written on that page, it is nothing but black marking on white background and the density of the colors. When you open that file again, the computer paints it back rather than printing or writing it back. So, though a scanned page can contain text, it will not be text to the computer. What are texts for a computer? Characters typed in it using the keyboard, mostly. Or we can use OCR, optical character recognition, to make the computer read the text from the scanned pages of the book. But OCR works only with printed texts. Because print follows a very definite pattern. For example, all A's will look same, all lines will have the same space between them, and things like that. A computer can be taught to recognize this. But then, if the page has an ink blot on it, the computer will be confused because it will recognize characters by patterns of black and white. That's the difference between a PDF made from scanned books and that's the difference between a PDF made from scanned book pages and an e-book where the text of the book is digital. So, what are the facilities of a digital text? Digital text can be easily manipulated. We can edit it, change it, search through it for a specific passage or word. We can rearrange it, annotate it, or even ask the computer to read it aloud. Now, how does the machine identify characters? It has a character encoding system installed in it. A character encoding system is a standard code that matches characters with some other system of representation. Examples of such encoding systems can be found in other fields as well. In fact, the most famous of them is Morse code, where a character is represented by taps or a combination of dots and dashes or electrical signals. Computer, at its core, can only understand zeros and ones. It understands binary numbers or a series of on-off signals. So it needs some something that will translate the characters as we write them into that form. The process is somewhat like this. We insert characters through the keyboard and it is received by the encoding system and translated into binary numbers. Then the computer processes it and stores it. Then when we need to see it, the encoding system retrieves the numbers, finds out the character image assigned to each one and displays those images together in order on the screen. These character images are called glyphs. A set of glyphs is called a font set. Each character image in a font set has a binary number assigned to it. Actually, the character encoding system in the computer has the legacy of Morse code. The Morse code was introduced in 1840s and it included all 26 English alphabet and the numbers from 0 to 9. In the 1870s, the Bodo code was developed from this, which is also known as ITA-1, International Telegraph Alphabet 1. It used a punch card and a combination, that is the presence or absence of 5 punch holes to define a character. Compared to the binary system we follow, we may call it a 5-bit encoding system. ITA-1 gave way to Murray code, which in turn gave rise to ITA-2. ITA-2 was the basis of 5-bit teletype code before ASCII. A 5-bit system means 2 to the power 5 combinations of 1s and 0s. So there are a total of 32 places to assign a character. But what is ASCII? ASCII is the American Standard Code for Information Interchange. It is a 7-bit system which can hold 128 characters. Later, it was updated to an 8-bit system which could hold up to 256 characters. This could include English alphabet in upper and lower cases, numbers, punctuations, symbols, and control characters that are used for instructions to the PC and not shown on screen. For example, enter or line break. We can think of it as a large table of 256 cells where each cell has an assigned binary number and holds a character. A font set attaches that binary identity to the character image or glyph. For a long time, ASCII was the basis of the character encoding system used in the computers. In fact, it is still being used, but it has its own problems. The 256 spaces worked well for a full set of English alphabet along with symbols, punctuations, etc. But when it came to the point of including another script in it, there was shortage of space. So programmers took the easy way out and replaced the glyphs of English characters with the glyphs of other scripts. This created a conflict because if you write something using such a font and I want to open that file using an English font, the text will be gibberish. One way to overcome this is to standardize binary codes, assign the first 128 cells to the English alphabet and fit the other scripts and all else in the rest of the cells. For the local language computing scenario in India, it was more problematic. Indian languages not only have vowels and consonants but conjunct letters too, a combination of 2 or 3 consonants and vowels. That increases the number of glyphs to hundreds. To fit them in the 256 cells, programmers replaced every glyph of English. It produced the same problem. If you do not have the font that was used to write the file, you cannot read a word of it. Moreover, you cannot use more than one script or a maximum of 2 in a single file. You cannot refer to the same binary value once as A and the next time as OR in the same file. The PC will get confused. But the more severe problem, if you consider it from the perspective of digital text processing, was that this system did not have any linguistic base. Take the example of Bengali. ASCII Bengali fonts have vowels, consonants, and then some separate images for conjuncts, without relating them to the particular consonants and or vowels that are combined to create them. So this text is useless for any linguistic or other kind of processing like search or collation. To solve this problem, Unicode was introduced in the 90s. Unicode uses a universal character set. It uses 32 bits, so that gives a table containing more than 10,000 cells. It can keep all known scripts in the same table, assigning a separate identity to each character. It actually has a table of assigned code points for a character, which then gets translated into a binary value. So, if you have a Unicode font in your machine that understands the code points for Bengali, it will have no problem in showing your text even if it does not have the particular font that you used. On the other hand, so much space can include different languages together. No problem using more than one script on the same file. And last but not the least, when you write a conjunct, it identifies that as a combination of the respective code points and not as a different character altogether. This makes it possible for us to identify elements within a word, analyzing or comparing them with words written in different files. Now, a book contains not only the text but also information about the text. We call these metadata, that is, data about data. It could be the name of the writer, year of publication, edition details, brief introduction to the text, as well as who created the digital text, for what purpose, who checked it, what software were used, what is the editorial policy and the annotations and things like that. It could also be a description of a physical book, its size and state, whose property it is, who is the copyright holder. We need to store these informations too along with the text. There are two ways of doing this. We can create a text and keep the metadata in a separate file, or include the metadata in the same file in such a way that the computer can differentiate those from the body of the text. This means marking this information in some way. This is called markup. We use a simpler kind of markup when we use HTML or hypertext markup language. HTML only contains instructions on how to display a web page. But in our case, we need XML, extensible markup language, which gives us freedom to create tags that fit our needs, depending upon the text and the type of information to be encoded. Information which I think is relevant for the identification of the text, record of the text's provenance, its importance, and the process of digitization. But if I create my own tags, I shall need to create a system that will read those tags, extract information and show them as different from the body of the text. Because I created the tags, I need to introduce them to the PC as tags and tell it what to do with them. If each one creates his or her own set of such tags and an interpreter particularly for those tags, they might serve the same purpose, but one's file could only be read by one's own software or the interpreter. There will be no way to exchange information. This brought up the question of interoperability. If I spend my precious time to create such a detailed and well-informed digital version of a text, it should be accessible and usable by the rest of the world. But for that, we need some common platform. A platform that can read many types of tag sets and display them accordingly. Or we create a standard tag set that we all unanimously agree to use. This presented the standardizations such as TEI, the Text Encoding Initiative. Like HTML, standardized and used under supervision of WWW, TEI is a standard set of tags that includes hundreds of tags, imagining almost every possible data that you may need to report within a text. The good thing about such a standard set is what you tag in your text will be interpretable on others' PC by using say some third-party software that was created to understand TI tag sets. Say one prepared a tool to fetch specific tags that contain the name of the speakers in a play. It will be effective for any text tagged using TEI anywhere in the world. For those who believe in the purity of the text, or at least try to keep the digital text as similar as possible to the printed or handwritten source, marking out the text within the file is not an option. There are other reasons for it too. The markup could be very complex and trained hands for it could be hard to find. It takes a lot of time too. Some text processing software can only take plain text as input and may not recognize tags and erroneously process them as part of the text. Even if you make the software aware of these tags, it may not recognize the whole lot, and most importantly, the tags will change regularly, get updated, and you will need to update your software accordingly. There will always be a chance of error and uncertainty. These experts suggest that we mark down the text instead of marking up. We use a minimum number of tags. Instead, we should use a small set of symbols to mark information and train our software to recognize those symbols, words and phrases within that as the informations. Or they suggest we keep a separate database for the metadata, and the text should be kept as clean and as similar to the source as possible. There are camps supporting either side because there are some advantages to both. We should remember that whatever we do when we create a document, it should follow the grammatical and linguistic rules of a language as far as possible in its character encoding, and some standard code must be used to create the digital file so that it can be used by others.